Then let's take a look. What is the process of communication? This will involve the name of a message. What is the name of this message? We can take a look. First, for the sender. We won't talk about the 7th floor, the 6th floor and the 5th floor. When our data passes through our 4 layers, that is, after the encapsulation of the transport layer, this data is called a segment. To our 3rd floor, the header that encapsulates what we call the network layer. We call it packets. This is what everyone means by sending a package and sending a package. The delivery process of the delivery package. In fact, it refers to the 3-layer data packet. To our current layer 2 data link layer. If we carry out 2-layer head and tail encapsulation, we call it frames. Then the frame, packet, and segment respectively refer to. We are just the name of the data on the 4th layer, the 3rd layer and the 2nd layer. You don't need to say this. What's the difference between them? There is no difference. Can you understand? No difference. It's just that each layer has a different name. The 4th layer is equipped with a 4-layer header segment. 3 layers are loaded with 3 layers called bags. The 2nd layer is called the frame. When the 2nd layer is installed, the head and tail are called frames. We will also decapsulate in the future. So its fundamental meaning is later. When we talk about a data frame, you have to know that we are referring to the 2nd layer concept. When it comes to the bag, it's 3 layers. Speaking of paragraphs, it's 4 layers. Sometimes when you look at documents, there will be some names like this. Each layer exists independently. The headers of each layer exist independently, but they are ultimately packaged in one piece. What we finally encapsulated is the complete classmates. It is not that it is completely encapsulated by several kinds of data. Is a complete overall data frame, packaged together, are added forward together, but they are really separated. We go down. Let's start with the transport layer. For the transport layer, we just mentioned the concept of a port number. For example, this is my local sender. For example, this is the opposite end. It writes a destination port here is 80. This means that we are accessing the HTTP service of the peer. It uses TCP port 80. That is, if you see the default port in the future, the destination port is 80. So by default we are actually using TCP. Such a reliable transport mechanism. Transmission Control Protocol. It's an overall big agreement framework. Our HTTP protocol is one of them. We say that with the help of such an agreement framework. To generate an agreement using port 80. It's enough for everyone to understand. That is, for the transport layer. First of all, when we encapsulate data in the future, our 3rd floor, that is, we actually encapsulate 4 layers first. Everyone needs to know 567. Let's not talk about encapsulating 4 layers first. There is an S in my local area on the 4th floor. Source port. It's a randomly generated port on my local. A random port. What does the random port mean? That is, we are randomly a port greater than 1024. Everyone understands this. Because we put 0 to 1024. We call such a port. They call it a well-known port. That is, we put the world. More ports used. For example, the following FTP, HTTP. Such ports are called well-known ports. Then, by default we put less than 1024. all less than or equal to 1024, are already equivalent to. You can't do arbitrary configuration anymore. They are some ports that we commonalize. We are admitting. You just say 80. It's the HTTP protocol. So when we go to the peer end locally, you have a port on the peer end. You must also have a local port. It uses 1027 here. I use my local port 1027 to access your peer. Assuming this is from a C company. Port 80 of company C's server. Can you understand? Port 80 of company C's server. Data sent to you. Then when you return the package to me in the future, the source and destination ports are to be swapped. Equivalent to when you send me now. The source is port 80. The destination is port 1027. So the equivalent of you are now on your local port 80 reply to port 1027 of my local device. Can you understand what I'm saying? That is us. The overall data communication is equivalent. If I have a port locally, I want to access another port of yours. When returning the package, you are also port back to port. This is our peer-to-peer reply relationship. So it's just a swap. This is our transport layer. Then the future port number is to distinguish our different network services throughout our CCNA curriculum. For example, we often mention HTTP 80, HTTPS 443, and we will often mention Telnet port 23. This is everyone in our agreement. We'll talk about remote login later. Then we log in remotely using Telnet. We are using port 23. This is what everyone needs to remember. You also need to recite. Basically, you don't have much to carry. There are some things I said to carry. You have to remember. Here are some of our transport layers. After the transport layer is sealed, we're going to the network layer. That is for the network layer. We have a little more to say. Let's take a look at it bit by bit. What is there for the network layer? For example, a basic IP header. First, let me tell you. I want to ask you a question. Since our data is encapsulated from top to bottom, we won't talk about the 7th floor, the 5th floor and the 6th floor. Let's default to 4-layer encapsulation. Everyone can see. What I am encapsulating now is an IP header. It's a protocol at our network layer. So it is equivalent to me that the 4 layers have been encapsulated now. This piece of data is called a data segment. We call it segment after 4 layers of encapsulation. Package is after the network layer header is encapsulated. Don't confuse this. But in fact, it is enough to understand. For 3 layers, there will be some parameters in the IP that are slightly more important. Everyone needs to remember. Let's look at the whole. I will pick a few important ones to talk about. First, here is a version. There are 2 versions of the IP protocol. One is version 4. The other is version 6. The version we use now by default is version 4. That's the IP address we're talking about now. The future will be IPv4 addresses. You will come to IE to learn version 6. Then the 2 sets of IP protocols of version 4 and version 6. In fact, its function implementation is very poor. Relatively speaking, the overall agreement concept, in addition to the overall framework design, is about the same. But the difference in function is a world of difference. But at this stage we are still using version 4. So we have to understand it as an header length. There will be a identifies our entire header length.